Alright. Good morning, everybody. Most of you guys have probably seen me before. My name is Mr. Irby, and today we are going to be doing a lesson on data. And we are going to use this data and see how we can incorporate it in the real world to help us solve problems. So, data. What do you guys think of when we use the word data? What comes to mind?
Graphs.
Graphs, okay. What else?
Information.
Information. That's a good one. Okay. Numbers. Good. Great.
Like phone usage.
Phone usage. Okay. What context do you mean?
Huh?
What do you mean? A little.
Like Wi-Fi. Like you have to have Wi-Fi.
Okay. Percentages? Okay. Good. One more.
Dates. Dates.
Dates? Okay. Okay, good. These are all good. So yeah, these can all be examples of data. All right. So for our task, can I get a couple of volunteers to help me pass out some books here for this side and any extras you guys bring back up here?
Okay. Also,
You have to pass somebody.
Definitely. And how much we need.
I ran out. Sorry. Those two need some.
I've been working on it.
I'm a math teacher, not an English teacher, so you have to forgive me on my spelling.
No.
Now, can I get a volunteer to begin reading this here? Hey guys? Nice and loud. Give me the first part there up to your task.
Have you ever heard about Newton's revenge? The new coaster. It was so big, fast and scary that we were excited earlier. Some people are worried about the tunnel that the girl ride designs with its closest. The closest is really the tunnel ever since the hero history is 2 million miles. Although no accident has been recorded yet, because of their tolerance and stuff.
Okay, so we have a brand new roller coaster that some of these taller people, myself included, are a little bit nervous about riding. Because there's a tunnel, and we want to make sure that I don't lose my hands when I go through this tunnel. So, can I get a volunteer to read your task and kind of a discussion question, please? Nice and loud. Sure.
Your task. Consider how you could determine whether the tunnel is actually safe for any rider, no matter how tall.
Yep.
What is the problem about? What is it asking you to do? What information can you help you answer the question? How can you get the information you need?
All right. So I want you guys to take about a minute and a half, turn and talk with your groups here, and talk about these discussion questions. And we'll come back here to your class.
I think we will find an average of how high the So I think we want to find that average first and then compare that to the height of the
It should be like 150.
Yeah.
Okay, back on me, class. Here. All right. So what did we determine? What's this problem about?
The height of the tunnel and the average of the height of these hands compared to the tunnel height.
Okay. And what do we want to know about that?
We want to know whether people are going to have to hold their hands down for when it's the tunnel.
Exactly. Is it going to be safe for me to go through the tunnel with my hands up? What information can help us do this?
The information that we need is the height of the tunnel, which is 270.
Okay, so we have the height of the tunnel.
And we'll also need to know the height of the rider.
Okay.
His hands up.
Okay. Anything else?
The height of the cart, so you know how high up the student is.
Height of, okay. One more bit of information there. What do we? Base? Well, it gave us that we know that it's 200 centimeters from the seat to the top of the tunnel. So what else do we need? We need our height. 3.
How tall are you going
How far up our hands go, our reach. Exactly. So, can I get a volunteer for 125 here? Okay?
One way to determine if a roller coaster is safe is to collect data. Collect data from each member of the team. Each member of the team needs to be measured twice. First, measure each person's height. Second, have the same student sit in a chair or desk, raise his arm, his or her arm, so that they are stretched as far as possible again, over her head. In this instance, and measure the distance from the seat of the chair to his or her finger, called the reach. All measurements should be recorded in centimeters.
Okay, so we have stations set up around the room, and we're going to break you up into your groups. And for each person, how many measurements are we going to take? 2. And what are those measurements going to be?
Your height and then sitting down.
3. And what are our units?
Centimeters.
Centimeters. Excellent. So, for you guys here, you're going to hit this station right over here. There's a chair and a meter stick for each station. You guys want this one right here. Okay. In the back, right by Miss Swanson. Let's see, you guys will be right here. You guys can go right there. And we got one more way in the back by the door. Okay?
In the middle.
Oh, in the middle, yeah, we got one more over there. So we're going to take our measurements, and as soon as you're done taking your measurements, one person from each group is going to come up and enter it into our graph up here. Okay? How many people from each group are coming up?
One.
Okay.
Numero uno.
6 people.
And we're going to have about 10 minutes to do this measurement. So,
Damn, no, it's ours.
Miss Swanson, where do we go? Where were you? Here? Yeah. Oh, guys, we're measuring each other. How many?
I don't.
No, you are not. You're like 270s. That's 270s.
Oh, the arm?
Yeah, the arm.
Really?
I'll go ask Mr. You're measuring me.
100 centimeters.
Yeah, because so that's what we're doing. Okay, and then I know it's one.
Jason, you want to go next or me? Jason, you want to go next?
Guys, do you see the measuring stations that you can use?
Yeah, but that's.
Probably be more accurate, Mark.
Well, use your meter stick from here.
Good. Stop moving. You're good. So wait, I'm 144.
Put up here and then use your meter stick to find.
You can ride the roller coaster.
You need to be careful where
Why are you using the one? There we go.
We just got there.
We're waiting. You're gonna need your data.
We didn't need
Data.
See, you can just undo print.
Hands up. Units on there, it'll do that.
hands all the way up.
You guys got all your data?
Working on it. We messed up a lot.
Yep.
Once you have your data, go start plotting it up.
Oh, we have to go put it on here. But
How many people go?
You see on the left side there?
one, Jason, go.
We probably should have not memorized that and just wrote it down.
There he is.
What do we measure her height?
175.
And she's older.
Yeah, so don't. You're not looking up the What is this?
What does it say?
Oh my God, T, you're your head eating those all.
Yeah, we do that. Okay, so what was it?
Read the whole sentence out loud.
Okay, stand up straight.
No, I said hurry. Yeah.
What we measure from?
I've been just a couple of days. Three feet and 10 inches. What's the centimeters? Oh.
You guys got all your data?
Thank you.
Yo, Nick, I'm gonna go up here. My height was 179, right?
I'm getting ground space.
Yo, Nick, reach was 181, right?
125.
Did you add all of those up there?
No, you only do one person.
You guys have all your data? You guys, I should start seeing a lot more data up there as you get it. Go, have one person go and enter everybody's data.
Alright, now sit down. Dude, you look like a freaking slurp. Stop it.
Bless you. Bless you.
Alright, yeah.
Everyone in your group, yes.
It looks over and go, they have a life size check.
Start on the back. Okay.
Work your data, get the clock up there. Start working on the questions on the back of the sheet. Once you guys have your data up there, turn your sheet over and start working on those questions as a group. You guys got your data up there? Yep.
How do your fingers?
What?
Oh God.
What?
Yo, I'm looking. Hear that?
What?
Yeah.
What?
Is this your last measurement? And start working on the back of the sheet there. Questions on the back.
I'm 74.
Got all your data up there? Yeah. So now flip the paper over and start working on the questions.
175.
Centimeter plus, my reach is centimeter.
Wait, what about?
Yeah. I think either next year or Pat.
You guys working on this? As a group, you can start working on all these questions. You can leave that together.
100 zillion, that's over in your pool. So, there are these people that start getting more and more data, they somehow get before they come out.
Like it's okay, or any way that people could.
Yeah. But we also are big ones
You gotta think in life, there's always going to be a
show like pictures.
So what we're trying to do is be able to spot that and see how it's going to affect what we're doing. You working on your questions? Yeah. Okay, so we'll start working on your questions, guys. You got it. Okay, start working on these questions. All right,
Great.
guys doing any questions?
Were those gonna be
Pretty close.
Lindsay who?
Class, everybody on me here? We're starting to enter our final bits of data here. What can we notice about our graph? Yeah.
There's two groups.
Two groups. Are you talking about two clusters of information?
Yep.
This guy and that guy?
Yep.
Why do we think that is?
Maybe girls and boys. Because there's no real middle to our classroom. It's either short people or tall people.
Short people or tall people, okay. Anybody else got an idea?
Because I'm probably that top dot.
Yeah, you barely got me. That much of a disparity. Well, look what we got going on here, though. So, what's our x-axis? Height or reach? Height. So we have people with similar heights with that much of a reach difference?
Maybe it's like the different chairs or something?
Different chairs. Well, these chairs are all pretty uniform, but should that matter? How did we measure our reach?
I think maybe it depends on the posture. Like if you're like lounge and you go like that, or if you're like, yeah, I mean, there could be a difference, you know?
Anyone else? What are you thinking? How did you guys measure reach?
My posture was great.
When we have similar heights, we're having a big disparity with our reach.
That's true.
So what's going on there? It's giving us two different clusters of information.
Maybe something measured it wrong.
Some people can have shorter arms than others.
That much?
Yeah.
Well, what can we say about our height versus our reach?
They're supposed to be almost like, they're supposed to be very close. In like that area, because my
As I
height,
get taller, what's going to happen?
your arm expansion will get longer.
Like, the shorter you are, like, the further down in the chair you're gonna sit, so to say. So if you're taller, if you have good posture, you're gonna be up higher in the chair versus short, you're gonna be lower.
Okay. I don't think that would make that much of a difference, though, Tegan?
I think some people didn't measure from the bottom up, but just the armpit up. Because I saw a few people doing that.
Okay, so Tegan, right?
Yeah.
You say there might be a measuring error involved. How did it tell us to measure our reach?
From sitting down.
Bottom of the seat to the tip of our fingers. How many of you did that? How many of you measured from the floor to the tip of your fingers?
I don't know. Probably.
I'm sitting down.
What about the armpit fingers?
When I'm sitting in a chair like that and I put my hands up, I should be measuring from the tip of my fingers to where?
To the seat.
Chair. Right? So if I measured from the floor to there, it's going to give me a lot bigger one. So, everybody that did it like up here and ended up measuring from the floor to the tips of your fingers, I want you to quickly go back and remeasure.
You want to retry? Yeah,
the seat.
Let's give it another go.
Tip of your fingers.
Go. Get it.
What's a quick way that you can adjust that?
You could just
Okay.
do it again.
Yeah, that's next time you specific measurement.
What's a quick way that you can fix your error?
Make sure that
He's still like the same.
something like that. Go.
It's like still the same. We did measure correct. You're still the same.
Yeah, I'm like the same. I just got long arms.
I think we measured it right.
Yeah.
Are we measuring that wrong?
Just measure it again.
Very intuitive.
Yeah. All you have to do
What do you have to subtract out?
Unless we measured it.
You don't really have to remeasure. Just measure the height of the chair minus
Oh, that's 6, Sam. Here, class. Sam's got a pretty good idea here. Sam, why don't you share with the class what you just told me?
If you just measure the height of the chair and then minus that off your reach, then That's all you have to do.
That makes sense?
Sorry.
Sam's saying if you take your initial measurement and just subtract the height of the chair, that's going to give you the correct reach measurement.
So minus 47.
Mine's 187 or
Once you
180.
guys get your remeasurements, go re-enter them in the computer.
Yards.
10:08.
Off your full measurement.
Again, from the ground up.
For me, I got 113. Halloween 2 or
Well,
Okay, class, as you get your correct measurement, come back and re-enter it into the computer. Fix your measurements in the computer.
Madison in the Wonderland.
you gotta just subtract it.
Wait, anyway, said there are any dots. So
Like
you see
20.
any dots that show human error?
We are Wonderland. 16.
How high is this?
Victoria and Wonderland.
47?
No.
So subtract 47 from all of these.
No, you do that.
Would you mind reading us the first question?
I do not mind.
Figure it out for me and tell me as I go up there.
No, what? I'm reading, guys. Subtract guys.
And tell me as I go up.
For your reach. Use the class guidelines. Hello. Hey, are there any?
Wait, do I have to change the ones that we did before?
Fix your reach height on there.
Any dots. Or that someone may measure incorrectly. Explain why.
Good.
Love going up on a Tuesday.
I don't see anything
Jason,
different.
what's Darius
Block,
saying?
and then you like
Alright, Darius is now 134.
What the heck? Okay, what's done? Or yours, what's yours?
What's mine? I'm figuring that out right now.
Okay, you take your time.
What do you guys notice?
I don't see any dots that show.
Remember there are two different other people measure bodies and
Full weight.
Alright, I'm 118.
Okay, what about me?
And then
Any trends in our data here? In other words, we're fixing our human error. Change yourself.
There you go, everyone. What's yours?
Nick Mike.
But
I just drink one.
Okay.
oh,
Addie going.
There you go. All right, this is starting to look a lot better, isn't it? Okay. Are you guys noticing any trends in this data as we fix our graph? Sam?
No, it's all in one group.
It's all in one group. Okay. Right in there. I'm going to zoom in on that one. She's here. So how, is there a way that we can represent this data in order to make a prediction? If you notice the last question on here, it's asking, can Yao Ming ride this ride? He's a pretty big dude. So how can we use our data to determine if this is safe for really tall people like Yao Ming?
Yeah.
Probably not.
How can we determine that? Everett?
Minus 45.
Well, we know his height,
Oh, I know.
but we want to know if his reach is going to be safe to go through the tunnel.
Well, on the picture it shows that it's 200 centimeters to the floor on the roller coaster.
Okay.
So if you minus 47, and then you get his height of his arms, then, or I mean, add the height of his arms with the height of the chair, and then you'll get that.
Well, I'm thinking I want to use this data that we have just gathered now as a class and use our data in our graph to determine if he's safe.
Yes.
How do we know that? How can we do that to make a educated guess, if you will, an accurate prediction?
I don't know, like if you can time, like if you, like times 2 to the, like the tallest person, and like, if you find like his height and then you times the tallest person in the roller coaster, like by 2, maybe you can find that way.
Okay. I don't know if that would give us a real accurate one. Really.
You could try to make an equation out of the data that we have, like find the average between all of them.
Okay, an equation. What type of equation do you think it would be? Think it would be like a parabola looking thing? Or?
I'm just looking at mx plus b.
Mx plus b. What's mx plus b? Equation of a what?
Of a line.
Of a line.
Oh,
Okay, so what would this line look like that would best represent our data?
Well, it's going to be like a scatter plot, so we have to find a line of best fit.
A line of best fit. That's a good word. Okay.
That time is one.
I need a volunteer. Come put this line of best fit up in here. Sam, you're awfully. Come on up there. All right. Now, Sam's gonna. You can do this pretty cool. You can move that green dot. Okay. Help Sam out. Let's find the line of best fit. Tell him. What do you think? Up, down, left, down,
Down.
Very down, boy.
Right. No, a little over to the left.
Oh yeah, move the top one left, other left.
Other left.
Not that, the top one.
No.
no, the left. Yeah, I think that.
What should our y-intercept be? What's
It
that?
should be negative.
0.
Why would it be 0?
Oh wait, never mind. No. Don't listen to me.
Why not?
Some did.
What does our y-axis represent?
The height. Or the reach.
Or reach. And what is this?
The height.
For y-intercept, what's your reach going to be when your height is 0?
0. Or it's going to be negative. No, it's not. It's going to be 0. No.
So what should our y-intercept be?
0.
Okay, so why don't you go ahead and fix your line there, Sam? Oh, now,
Move down a bit.
Yeah, a lot off, man.
Down, right, down.
Yeah, I think that.
everybody like that? So can we now use this to make a prediction for Yao Ming?
Yeah.
How so? Thank you, Sam. How can we use our information we have now to determine if Yao Ming can ride this? Well, we have our line of best fit, but now how can we use that to determine if Yao Ming can ride?
Well, I don't know. Like it shows the highest person at the end. Right. Like I don't know.
Maybe. Maybe find an equation and then put his total height into the equation and figure out if he could ride it or not.
Okay.
So let's just find the slope and all that stuff and then put it in like an x and y equation like mx plus b and then
Okay.
see where his plot would be in the
All right, why don't you guys take a few minutes and work as groups and see if you can determine an equation for this line.
We're on the last one. Well, Yomi, he didn't, you guys had to remeasure, right? So you didn't get this. So is it safer to that? We'd rather have accurate data. Do you have to do that with like a machine? I don't know. Is it safer than that? Anyway, that's not really.
I'm like starving. Well, I
One question on the oh wow.
really if that's at.
Class,
Then I'm assuming it's.
how many of you guys found an equation for this line? Anybody find an equation? No, we're still working on that. Is there any other way we can determine just by using our graph?
Oh, I
You
think
Tegan?
I think I know.
I think we can use me actually, because he's a full third above me, which my reach when we were doing it was up to 180 centimeters and such. And so I'm thinking that's a whole. You'd have to add a whole foot and a or third onto my reach, which would obviously be above 100 or 200.
And we know his height. It gives us that on our paper. It's 228 centimeters.
Oh, we have to,
Yeah.
we have to figure out how much the cart is, right?
Well, we know it's 200 centimeters
Yeah,
from
from
the
the
seat.
top, like the seat to the thing, but
We
you have
know
to
his
figure out
height.
from the seat to the track, like to the train bit. You know, we're not worried about those.
Does it tell you the
Yeah, that's still a track.
Yeah, 200.
Roller coaster
That's our
track,
max.
you never heard of that?
That's our maximum there. Sam?
Well, since he's 228 centimeters, I think if we just follow the line up
Come
to.
up here and show me again
Okay.
what you're talking about. Which line you talking about?
So, this part over here is the height, right?
That's our reach, yep.
Okay. So, now if he's about 228.
Well, this is going to be our, what's our height? X or Y?
X.
Okay, so that's going to be
Okay.
down here.
So it'd be about here.
Okay.
So that's 228. So from his reach, he would be 171. And that's from the floor. So we would need to minus 47, which is the chair height.
So Sam went and followed our graph, used our graph, and found that Yao Ming's height's going to be somewhere right around in here. And then he just went up and found where it hit on our line of best fit. And that gave, so is he going to be safe?
Yeah.
Yeah.
How do you raise
How do you know?
the average?
Well, because his reach is only 171, but from the seat is 200 centimeters in the tunnel, so he would still have room.
So according to our graph, his height is going to be exactly 171?
No,
No?
a little more.
A little more, could be a
Just
little
around
less.
there.
Yeah.
We got falling on both sides of this line, so is this going to be the exact amount for our line of best fit? No. But it's going to give us a what?
It's rounded.
It's a pretty good approximation. Yeah. Awesome. So according to our data, Yao Ming is good to go. What do you think would be the tallest that someone could be and still feel safe and comfortable riding it?
Well, you just follow the line.
To where?
247, which is about right here.
Okay, go ahead.
I think they could be 300 centimeters or less.
300?
It would have to be less than 300.
Cool. So you're saying it's going to have to be less than 300? Somewhere in there. Okay, go ahead.
I assume maybe like they have to be 250 or like 250 or less, because once you start getting closer to 300, it's gonna the reach is gonna start going over the height of the tunnel as you get closer, so it should be like a
So
little
you want
less.
to find where the reach is going to be below that maximum. Which
Yeah.
Yeah. All right. Awesome. You got that. Thank you guys very much.
Thank you.
Do have a break.
Guys, I'll check homework on that next.